For our first FOMO lab, we investigated 2D inelastic collisions.
Our research question for this lab report was, how does altering the velocity of an object just prior to collision affect the inelasticity of the collision?
In investigating the relationship between the initial velocity of an object and the resulting inelasticity of the collision between the two objects, it was found that a lower initial velocity resulted in a higher coefficient of restitution, meaning that this collision was, relative to a higher initial velocity, more elastic. The significantly higher coefficient of restitution for trial 2 is largely due to how there is a more x-direction motion in trial 2 relative to trial 1. In addition to that, how the coefficients of restitution for the x-direction in both trials had to be neglected as they were undefined.
These models show the differences in the setups between trial 1 and trial 2. It should be known that the mass of ball 1 is larger than the mass of ball 2.
Because of the fact that we are investigating the collision by itself, our system boundaries are around ball 1, the ball rolling down the ramp, and ball 2, the ball 1 is colliding with.
Our energy pie charts model the energy flow in our system boundaries as gravitational energy before the collision is converted into kinetic energy as ball 1 rolls down the ramp, collides with ball 2, and energy is decreased.
The independent variable of this experiment was the initial velocity of ball 1 rolling down the ramp. In order to change this, we altered the height of the ramp. Beginning ball 1 at a greater height would result in a greater initial velocity as it collides with ball 2 on the ground.
The dependent variables being measured were the velocities of ball 1 and ball 2 after the collision, aka our final velocities. The constants we kept in this experiment were the masses of both ball 1 and ball 2, the object used as a ramp, which was the whiteboard, the initial velocity of ball 2, and the initial position of ball 2.
It is important to note that the two dimensions that we considered in this experiment were those of the plane of the ground rather than the vertical height of ball 1's initial position. Therefore, we began data collection just as ball 1 reached the end of the ramp on the ground on the same plane as ball 2.
Next, we are going to show our trials 1 and 2. Trial 1 is with a lower velocity, and trial 2 is with a higher velocity. These trials are shown respectively.
Put it farther out, because that's in the collision path. We have to include that in the collision. Yeah.
Some of the flaws and limitations of our experimental design were that the whiteboard was not perfectly level. This could have resulted in random error over different trials. There was also human error associated with releasing ball 1 from the top of the ramp. Reliability of data depends on the trajectory of collision being precisely identical every trial, which could not have occurred. Slight error involved in using tracker software to measure, friction not taken into consideration in energy calculations and models, internal energy not being quantitatively considered, and it is assumed that the x-direction initial velocity of ball 1 is 0 meters per second.
This slide displays relevant energy equations. We used the gravitational potential energy to calculate the initial velocity of ball 1.
The conservation of energy principle is a very relevant concept in our experiment because in a system that includes the Earth, energy is always conserved because energy is neither created nor destroyed, but is always just converted to other forms. However, in the case of our experiment, since the system of the experiment only includes ball 1 and ball 2 and refers to kinetic energy only, the energy decrease is presented in pie charts due to the fact that energy lost due to friction is intentionally neglected. Some of the kinetic energy present before the collision is lost as heat afterwards.
The coefficient of restitution was calculated by finding the initial and final velocities of each ball in the x and y direction separately.
In trial 1, when ball 1 was given a greater initial velocity, the y component of the coefficient of restitution is very close to 0, implying that this is a very inelastic collision.
In our second trial, where we lowered the initial velocity of ball 1, it was found that the coefficient of restitution in the y direction was significantly larger at 0.102. However, this value still being close to zero represents a high inelasticity in a collision.